theorem on linear combination statement. If S is equal to V1 bar, V2 bar, Vn bar, basis for vector space V, then for any vector V bar belongs to V can be uniquely expressed as linear combination of the basis vector So proof. So what is given? Given S is equal to V1 bar, V2 bar, Vn bar, basis for vector space V. Now what is our claim? And we want to prove that, and that is we want to show that here. Claim vector V bar belongs to V, any vector can be uniquely expressed as linear combination of linear combination of the basis vector. So now proof. So now since given S is equal to V1 bar, V2 bar, Vn bar, basis for vector space V, this implies set S span V, that is Ls is equal to what? V. That is every vector from V can be expressed as a linear combination of V1 bar, V2 bar, Vn bar. Now suppose V bar is equal to, say, alpha 1 V1 bar plus alpha 2 V2 bar plus alpha n Vn bar. Why it is possible? Because since set S span V, because of this. Span means what? Every vector V belongs to V can be expressed as a linear combination of vectors in set S. And suppose V bar is equal to beta 1 V1 bar plus beta 2 V2 bar plus beta n Vn bar. So these are the two. Suppose we express V bar in such a way that, now if we write here, this V bar can be written as V bar. If we write here first V bar plus minus V bar. So what is minus V bar? Say this is if this is a V bar, then what is its minus V bar? Minus V bar is equal to minus beta 1 V1 bar and so on. Okay, so we write this as a alpha 1 V1 bar plus alpha 2 V2 bar plus alpha n Vn bar plus what is minus V bar? It is minus beta 1 V1 bar minus beta 2 V2 bar plus minus beta n, this is what? Minus beta n Vn bar. But what is V bar minus V bar? The value of this on the left hand side, it is what? 0 bar. 0 bar is equal to alpha 1 minus beta 1 V1 bar plus alpha 2 minus beta 2 v2 bar by using which property? By using, this is what, m1 m2, sorry, what is m2, from vector space V. I am writing here by using different color, say choose different color. I am writing here, say what is m2 in vector space, alpha plus beta v bar is equal to alpha v bar plus beta v bar. By using this property we can write this as, since this two vector alpha 1 v1 bar minus beta 1 v1 bar can be written as alpha 1 minus beta 1 v1 bar, and continue so on. Finally we get alpha n minus beta n vn bar. Okay, vn bar. Now since v set S which is equal to v1 bar v2 bar dot vn bar basis, this implies yes, set S is linearly independent. So linearly independent means what? If we write this v1 bar v2 bar vn bar in a form of in alpha 1 bit k1 v1 bar plus k2 v2 bar plus kn v1 bar, implies all these scalars equal to 0. So what is scalar value here? This implies alpha 1 minus beta 1, this implies alpha 1 minus beta 1 equal to 0, alpha 2 minus beta 2 equal to 0, and alpha n minus beta n equal to 0. But what this implies? This implies alpha 1 is equal to beta 1, alpha 2 is equal to beta 2, and finally alpha n is equal to beta n. So if we here suppose here we write v bar as a suppose it is possible, suppose we assume here that is v bar can be expressed as a linear combination of alpha 1 v1 bar plus alpha 2 v2 bar plus alpha n vn bar, and v bar is equal to beta 1 v1 bar plus beta 2 v2 bar plus beta n vn bar, and finally we reach what? Alpha 1 is equal to beta 1, alpha 2 is equal to beta 2, alpha n is equal to beta n, that is alpha I is equal to what? Beta I. So what this implies? This implies a vector v bar can be expressed if set S is basis for V, then v bar belongs to V for any vector can be uniquely expressed as linear combination of linear combination of the basis vector. Okay, so hope you understood this. So what is meant by linear combination? So for example, if we take the simple example, say S is equal to, say V is equal to R square, and take S is equal to, say 1 0 and 0 1. These are the what? Trivial basis for, that is what is here, E1 bar is equal to 1 0 and E2 bar is equal to what? 0 1. Then if we take here vector 2 3 in V, then this 2 3 can be expressed as 2 times 1 0 plus 3 times 0 1, that is 2 times E1 bar plus 3 times E2 bar. So we express this 2 3 as a linear combination of E1 bar and E2 bar. So this is 2 3 is called linear combination of E1 bar and E2 bar, and this is what? This is unique representation. Why it is unique? Because since E1 bar and E2 bar basis for R square, these are what? Basis for R square, basis set for R square, and that's why this combination, that is what here, alpha 1 2, alpha 2 is what? 3. These scalars, these are unique scalar. So